So hello everybody. This is chapter 4 now, and chapter 4 mainly concerns itself with interest rates. That's the theme here, so we can go further. And we're going to talk a little bit about interest rates. This is not a large chapter as far as slides go, so we'll proceed with this. All right, so the first thing is you've probably heard this term, and if you haven't, present value. So basically, a dollar paid to you 1 year from now is less valuable than a dollar paid to you today, and you realize that that is because of you could take that dollar today and invest it, right? So, but in reality, I guess with banks the way they are, if you look at it from a bank standpoint, it's not really that much of a difference. But theoretically, it's worth more to you today. So, I mean, they have a nice little example right here, right? So if I gave you $20 million today versus a $1 million a year, the question is, are those two values the same? And no, they're not. And this is why most people take a lump sum from the lotto. You ever see when they win lotto, they give you a choice of payments or a lump sum? And so you could invest that money, right? So here's a calculation of present value, and that from the previous slide. And again, this is almost, if you've had undergraduate or just some basic courses in finance, you'll understand how to calculate present value. And this could also be done with Excel. All these functions, by the way, are all built into Microsoft Excel. So you might want to, look at that, and you could email me, and I could go through this with you if you'd like, or I can do a special presentation on using Microsoft Excel to do finance calculations. So here's a simple present value slide, okay, of a single amount, right? I see if it's just one amount, not an annuity, and here's the way it looks on the timeline. All right, so just a simple loan. Let's go through these four terms together. A simple loan is just that. I loan you $1,000 today, or right, and I say pay me back in a year, and give me 5%. So if I loan you $1,000 and say pay me back in a year, that's $50, right? All right. So the next thing is a fixed payment loan, right? When you go to the bank, well, your mortgage is a fixed payment loan, right? You get that fixed payment made every year. And again, all these can be calculated by Microsoft Excel. And a coupon bond is you loan a company money, and they agree to pay you a coupon back in, in a year. Let's say every 6 months. Most bonds are paid coupons in every 6 months, right? And a discount bond is like a treasury bill, I'm sorry. You pay a very low price for a treasury bill, and you don't get any coupons. And then when the bond matures, you get basically the full amount, including the interest that you did not get. By the way, on bonds, you always get your money back at maturity, right? So just want to make that clear to everybody. All right, so the yield to maturity is simply the interest rate that's going to equate the present value of the cash flow payments received from a debt instrument with its value today, right? So that's the actual yield you will get when it matures, just like it says, to maturity. And here's the calculation again for a simple loan. And for a simple loan, you can clearly see the calculation is the same. The simple interest equals the yield to maturity here. And again, if anybody wants to go into more detail, you let me know and how much more detail I could make videos. Here's a fixed payment loan, right? And this is the loan that we basically get from a bank, right, for your mortgage or whatever. And there's your fixed. Well, it says fixed yearly payment, but it could be your monthly payment too. And this could be divided by 12, a monthly interest rate. So it all depends on how you do the calculation, right? Whether you do it over an annual time or a month. All right, so again, here's a coupon bond, and you'll notice here's the coupons you get every 6 months, right? And it says yearly, but most bonds will pay it in every 6 months. And here's you're getting your principal back with the face value. Let's say it's $1,000. You get that back at the end of the year. All right, so here's a couple of things you have to know. All right, so the price of a bond, and everyone should notice the price of a bond and the interest rates are always negatively correlated. When interest rates go up, the price of a bond goes down, and when the interest rates go down, the price of the bond goes up. So there's a couple of things, and I believe I have some stuff on Facebook. On Blackboard, where I could. You should be able to read these things. So here's different prices of bonds. You'll notice that this is up. So this is lower, this is going down, that's going higher. Notice as the price goes down, the interest rates go up, right? And the coupon is 10%. All right, a perpetuity, there's nothing simpler than a perpetuity math-wise. It's just the price of the bond. They call it a console, but it's the price of the bond divided, and it's the price of the bond is the yearly interest payments divided by the yield to maturity. And here's like a Treasury bill, a discount bond, and there's like a Treasury bill. You can calculate the yield two ways, right? It's done two ways, and I could send you information on that if you want further detail. All right, so the rate of return. All right, so this rate of return is like with a stock, right? With a stock, here is the dividend, right? This could be the dividend when you own a stock, right? And this is, notice that this could be the capital gains or the price of the stock going up. So this is your actual rate of return plus the change in value, all right? So again, here's the here's that whole discussion I talked about. So the capital gain is G. This is the capital gain, and this could be the dividend, right, or the coupon. Either way, whether it's a stock or a bond, you could look at it that way. All right. So there's a couple rules here. Go over these if you have any questions. All right, so here's a nice table that kind of shows you the current yield on a bond and the initial price, and here's the price next year. So the bond pays a 10% coupon in all cases, right? So here's the initial price. Here is the price of the bond next year. It's gone down, so that your capital gains have gone down, right? And so your rate of return is this minus your coupon, so it's minus 39.7. Just subtract these numbers from this in all cases, and you'll get this term. All right, so if you hold the bond to maturity, right, you don't have to worry about interest rate risk because you're going to get the money back and you're going to get the constant coupons, so there is none. All right, so the nominal interest rate is basically makes no allowance for inflation, and the real interest rate basically will, and it reflects the cost of borrowing. All right, so I'm not going to go too much into the Fisher equation here. But basically it simply says, the math is simple, right? The nominal interest rate is the real rate plus the expected inflation rate. That's really about it. So here's a table that shows the nominal rate and the real rate, and you can see they track, right? And the nominal rate has the bump up for the inflation there. All right, so this is a short chapter. That's about it. And if you have any questions, see me. Or email me, and I'll always send you more stuff all the time.